Hello everybody. I hope you're doing well. Again, it's sort of a pretty common opening for these videos actually. Today I'm going to be showing you how you can use breakpoints and live expressions when you're debugging for STM32 microcontrollers. So it's really simple. It's not going to take too long, and I've already written a demonstration program that we're going to go over. You can see from the outline here, there's this variable called counter that I have. It's an integer, it's set to 0, so you can probably guess what this program is going to do. If we come into our main function, we don't need to worry about any of this setup and configuration. I'm using one of the STM Nucleo boards, the F446RE, and when I configured this project, I just set it up I used the board selector for that specific board and just initialized sort of everything, whatever components the board had on it. It's not really needed for this video, but what I have here in this main loop is a counter variable, and we increment the counter every loop. Then we call our hardware abstraction layer delay function. We wait 1000 milliseconds or 1 second, and we check on the board itself there's a blue pin, not a blue pin, a blue button. We check to see if the button's been pressed, and if it has, we want to reset the counter. Already there's a problem with this, is that if we're in this delay function, the microcontroller is not going to be polling or checking. There's no sort of interrupt set up. It's not an asynchronous process this here, but it's a very simple program. I wrote it in about 5 minutes. So we're more focused on understanding how the breakpoints work, as well as the live expressions. So if you build your project and then come up to your debug configuration here, you can open your debug configuration. We're going to select debugger. We're using a serial wire debug interface, and if you're using an STLINK, which I recommend, that's not a bad idea. Why is it not a bad idea? I'm not sure, to be honest. We can probably look that one up. Maybe there are some more debugging tools, but it's not something I've used when using the Nucleo boards in particular. I think they've got an STLINK built into them. I'm gonna go ahead and hit debug, switch to our debug perspective, and we've got a few buttons on this interface of importance. We've got this play pause button, our stop or terminate button, and we've got these here that we can control breakpoints with, so we can step into or over bits of our code. On the right hand side here as well, you'll see we've got variables, we've got I think that says breakpoint, expression registers, and live expressions. And if you come to the live expressions tab, you can actually see I've already added this in, but you can type in the name of your variable. So if this wasn't here and we type in counter, you can see that the counter of type integer has a value of 0, and that's consistent with what we defined at the top of our program. We have our integer counter, and we've just set it to 0 here. And if I go ahead and run this program, what we can expect is that the counter will increase every 1 second so long as I haven't pressed the button. So we'll go ahead and do that. I'm going to just pause this for a second. So it's paused it for me, I suppose. I'm going to toggle this breakpoint off because we're not looking at them just yet. So we'll go and hit run. What you can see in this live expressions here is that your counter is increasing, and this is really powerful. We're not using any sort of print statements. You don't have to worry about a separate UART connection that you might be using in the sense, and that's how you may have been debugging in the past. You might be doing some form of serial print statement and reading that to some sort of comms program, and that's a very inefficient method of doing it. I know this program's not the best example for demonstrating the real power, but it's just a really quick sort of introduction to how to use these tools, what they are. So you can see that our counter is increasing, and if I press and hold the blue button just to make sure that the program runs into that block of code, it will reset when I've pressed the blue button. So what we can do next is we can pause this program. You can see the counter, it stops counting up, and we might want to add in a breakpoint. So we'll go back to our it changed the tabs for some reason. We can come back to our main.c program, and if we toggle a breakpoint just by right-clicking at the right line, I right-clicked, secondary clicked at counter, this counter line here. We go ahead and click play or run. Then the program is going to stop. The debugger is going to allow us to step through this program line by line, so we can see what's happening. So we're at this counter line where we want to increase the counter. So if we step over this line, or we step into this line, because it's just an incrementation of a variable, we'll go step over. You'll see that our counter value has increased by 1. We can step into this hardware delay function, this hardware abstraction layer delay function, and that will actually take us to where that function definition is, and we can see what's being called by the function itself that we haven't written. But I won't do that, so we're going to go and step over that as well. So that's going to take a second because that's calling that function, and it's just a blocking wait. And now we come into this if statement where we're checking whether or not the button's been pressed or not. It's not pressed at the moment, so if I step into, it's actually just going to take us back to the top of the while loop. Okay, it will take us eventually, but did I go into or over? I pressed stepped into, so this is actually, well, this is how on the hardware abstraction layer, how you would write a check to see what the pin state would be. So we're just going to step over all of this, and this is going to take us back to the top of our program, which is what we expect. If we do this again and we come back to our same line, you can see the values increased again from 17 to 18, and this time I'm going to hold the button down, and we're going to step into it again. It's going to check the state of the pin, and given that the pin is depressed, I'm holding it down, it's going to return a reset, which is a 0, and if it's not a 0, because this if statement is, I've got this exclamation mark here, if it's not 0, it's 1, so this expression returns true. This counter variable will reset as we step into it again, and our value is reset to 0 when we're back at the top of the loop, and we're back at the top of the loop. So I hope this has been an interesting enough video. It's just been very quick, how you can use breakpoints and live expressions to debug your code faster, get away from the serial print statements, and this is a really powerful tool. It comes in use a lot more when you're working with more time-critical applications where adding in a print statement and reading out the output into some sort of console or comms will add a significant amount of sort of overhead or processing to the processor, and you just don't have those resources available. That's when you can come and use a tool like this, and especially with the breakpoints, being able to step over your code, figure out where your logic is directing you, and maybe you've made an error, and you'll be able to follow through how the program is running to try and better debug this, rather than slapping print statements left, right, and center, trying to figure out is it this function that's called or this or this. You can actually see in a really easy to understand and simple, straightforward way how the program is running. So if you've enjoyed this video, like and subscribe or not, it's really up to you. But we'll see you in the next one. The next one's probably going to be on thermistors. So if that's interesting, stay tuned. And if it's not, then maybe make some suggestions. If you have any ideas, leave them in the comments. Any questions, I'm happy to do my best to answer them.